Hi everybody, Patrick here from EngineeringShock.com and electroniclessons.com. This is video 2 of 3 regarding the DIY solar tracker kit. It's just a mini solar tracker. Right now it is tracking light. A little bit difficult to do that properly considering that there's lots of fluorescent and sunlight coming into this room at different angles right now. But it's focusing in the general area, as you can see. If I turn it this way, it will start turning towards the window, as you can see. Anyway, so these kits, these are the electronics that are required for the kit. We're going to go through what's here, and we're going to go through the assembly process. So let's see what's included with the kit. What you're going to need to put this all together into a kit is a soldering iron, solder, hot glue gun, and glue sticks. And perhaps even a bit more imagination than I have. So what this video is going to show you is how to put together the main components and how to interface everything together. The next video will give you some tips as to how to physically put it together. So let's get started. This is the 5-volt regulator, 7805. This is a standard PCB that will serve as your sensor board. This is the main interface board, where most of our components will be soldered. This is our stepper motor driver board. It connects to the stepper motor seen here via the prototyping area on the main board. This is your programmed microcontroller, 18-pin socket, a single 0.1 microfarad ceramic capacitor, 100 microfarad electrolytic capacitor. These are your supply capacitors. 3 LDRs, light dependent resistors, photoresistors, and 5 10k ohm resistors. Also, 2-pin terminal block for power, and a bit of wire for your whiskers, and just some interface wire. More than enough both for the entire project. So first of all, let's consider wiring up our main board. It's fairly easy, but we'll get the power supply components and the microcontroller components out of the way first. We'll do the sensor board a little bit later. I forgot to mention one component, monetary tack switch right here. We're going to be soldering it in during this step. You need 2 of your 10k ohm resistors, and you want to place one into the RA3 slot right here, and one into the RA5 slot right here. When I'm done this step, I'll actually show you the board so that you can compare with yourself in case you have any problems. Again, that's RA3 right below the 2 pads here labeled LED enable, RA3, and RA5, which is right above the cell 2 switch footprint. Solder those in. There's no polarity on resistors, of course, so you don't need to worry about switching those around. Your tack switch should fit in only one way and should be placed in the cell 2 footprint right here. Pops it in place. Make sure it's flush with the board. It shouldn't be a problem. Solder all 4 sides in. Your terminal block. There's 2 sides to a terminal block. There's a plastic side and the side with 2 terminals. Make sure that the side with 2 terminals is facing outwards, because that's where you're going to apply your 7 to 12 volts DC. If you turn it around and the terminals are facing the far side of the board, you're going to have a heck of a problem getting it out. It's not easy to remove. So be careful before you solder and double check that. Now, the regulator. There is a gray side, sorry if it's out of focus, and there's a side with writing on it. Make sure that the gray side is facing the white stripe on the board for the regulator slot right here, so that the side with the writing, the black side, is facing the left side of the board, and that the gray side is facing your tactile switch. Now we want to worry about our 2 resistors. Our 2 resistors go in the C1 slot and the C2 slot. C1 is labeled 0.1 U, and that is a 0.1 micro. There's no polarity on the ceramic 0.1 microfarad capacitor, so place it in there and solder it into place. Don't worry about polarity. Now your 100 microfarad electrolytic capacitor does have a polarity, and on the left side of the board there's a little positive sign. Make sure that the longer lead of the capacitor is placed in the left side of the board, and then the shorter lead, the negative lead, is placed in the right side. Again, a capacitor, the electrolytic capacitor, hard to see here, has a long lead and a short lead. Long is positive, short is negative. So place the long lead in the side with the plus sign, shorter lead in the other side, the side facing our microcontroller slot. So let's solder all of those components into place, and next we'll do our socket and our IC. Our microcontroller slot, labeled IC2 PIC 18F1220, has a socket and a program PIC. Now, in the upper side here that I'm pointing at, on the footprint, there is a notch right above the IC2 label. On the socket, on one side there's a notch, and on the IC there is a notch on one side. Make sure that the notch, both notches for the socket and the IC, are facing, from a bird's eye view, the notch on the footprint. If you do not do this, if you put the IC in the wrong way, you will likely burn your IC and your project will be toast. Well, that's a bit dramatic. You just need a new IC, but still that sets you back. Not fun. So make sure that when you solder in the connector or in the socket, that the notch is facing the notch on the footprint, and when you place the IC in the socket, that the notch is facing the notch on the footprint in the socket. Now, when you're soldering that into place, make sure that there's no shorts. It's very easy to short if your soldering is subpar. If you have any shorts, you can damage the circuit, and even if you don't damage the circuit, you can certainly mess up the functionality of the device. And you'll notice very soon whether or not that's actually going to happen. Anyway, so next we're going to do our driver chip. We're going to place it in our prototyping area. And that's a little bit more tricky, but we'll get to that step in a minute. Now here's a tricky step, and you have to be very careful. First thing you should know about the prototyping area is that all of the top slots are all connected to 5 volts. It's labeled 5 volts on the board, so every single one of these top slots is connected to 5 volts, regulated from our regulator. All of the ground ones, all of the bottom ones here, all of the bottom slots are ground, and it's labeled on the side, GND. On our motor driver, there are 6 pins. One's labeled VDD on the left, then in 1, in 2, in 3, and 4, and ground. So we want to make sure that when we put this in, that we manage to get our VDD pin on the left connected to any one of the pins on the 5 volt line, and our GND pin with the rightmost pin connected to any one of these bottom pins. So that's powering the board. Forget about the in 1 to in 4 pins right now. We want to get this soldered in. So what I would suggest doing is placing it in the middle of the board, soldering it in flush down into the board, making sure that there are no shorts, and then taking a wire and from underneath tying the leftmost pin, VDD, to one of the 5 volt slots, and taking another wire from the bottom and connecting your rightmost pin, your GND ground pin, to one of the bottom slots connected to ground. So before you do this, let me solder it in, and I'll show you what it looks like from on the bottom of the board. By the way, make sure that the white slot is facing the front of the board, as seen here. So as you can see, I've added a little wire connected from the pin to the 5 volt line, and another wire between the ground line on our driver board to the bottom rail, which is all interconnected to ground. So now the next step is going to be wiring our driver inputs to the I/O port, the relative I/O ports of our microcontroller, and it's actually easier than you may think. Now all we have to do is wire our in 1 to in 4 lines to our port lines. Now, if you actually look on here, there's 2 sets of rails. This is for port A, and we'll be using that later, and this second one is for port B. We're going to be using the I/O ports RB0 to RB3. Now, if you look on the secondary rail here, there is a line called 5 volts, so that's just a 5 volt line, ground, and then RB0, RB1, RB2, RB3, and so on. So what we want to do is we want to connect our in 1 line from our driver using a wire to the RB0 line right here. We want to then take a wire, some of our included wire, and neatly tie our in2 line on our driver to the RB1 line, in 3 to RB2, in 4 to RB3. It's quite easy to do. Just make sure that there's no shorts, and make sure that when you add wire to one of the holes on the proto board, that the wire from underneath is actually connected to the driver lines. Now again, in1 to in4 is labeled on the front of the board. You can't see it from this perspective, but it should be relatively easy to do. Just make sure that you're actually tying them to the right lines. It might be difficult to see from here, but it's very easy to see when you have this in front of you. So do that wiring, and we are done with the main board for now. We'll then work on our sensor board. After you solder those into place, if you have a multimeter, do a continuity check between these pins, these pins, these pins, these pins, just to make sure. As well, make sure that there are no shorts. Now we are done with the main board. What we're going to do now is we're going to talk about the assembly of the sensor board. The schematic is very simple, but you have to pay close attention and be very careful in the process. But again, we'll talk about that in a minute. Next, we'll talk about what components go where, and we'll talk a little bit about the sensor board schematic. Pardon the presentation here. I know when it comes to writing schematics, and in fact my handwriting is absolutely brutal too. I'm used to doing everything in Eagle and AutoCAD. But anyway, this is the schematic. Very easy to do. There's actually five wire interface for the main board. There's actually 6 wires. We're going to probably talk about the sixth wire later. The wires that we need to connect between our main board and our sensor board is 5 volts, ground, and A, B, and C. Those areas. Now, we'll get to A, B, and C in just 1 minute. 5 volts powers 3 series strings of a 10K resistor in series with an LDR. The LDR, light dependent resistor, is right here. Your resistor, your 10K resistor, is right here. So by placing those in series, the resistance of the LDR changes based on how much light is hitting it. So we'll get essentially getting a voltage divider effect on in between the 10K resistor and the LDR in the case for A, B, and C. As you can see, 5 volts is connected to each of the 10K resistors, and we place in series with that the 3 LDRs, and the secondary pin of the LDR is connected to the main ground line, so all 3 of them are connected to ground. Don't worry about soldering A to B and C right now. First of all we really want to do is we don't even want to connect 5 volts or ground. We just want to make this. Place all of your resistors on the 5 volt line, and then place your LDRs in series with them and have all the secondaries connected. Now, neither the resistor or the LDR are polarized, so it doesn't matter which way you solder them into place as long as you don't have any shorts. So before you do that, let me just show you how I did mine. What I did was I placed the first set of the first series LDR and resistor set on the as far left as possible, leaving some space at the top. We'll get to that later. And the rightmost set as far right as possible. And the middle, you have to fiddle with it. You just make sure that this middle set is in fact in the middle, proportionally to the left and the right. And from the bottom, what you can do is just use some wire to connect all of the bottoms of the LDRs together, and we'll connect that to ground later via a wire interface to our main board. The top, as you can see, I've used some wires to make sure that all of the tops of the 10K resistors are connected together, such as seen here. All 3 are connected, 1, 2, and 3. And in the middle, you might not be able to see it very well from here, but there are basically 2 blobs connecting the top of the LDR and the bottom of the 10K resistor, here, here, and here. Now we'll want to add some wires there, but there's actually one more step regarding something else that we have to do. As well, we also have to manipulate the board a little bit. So first of all, we're going to put our whiskers on. Now this is actually a very easy step. What we're going to need to do is take some of our solid wire, make it as flat as humanly possible, and make a piece about that long. so that we get about an inch out to the right and an inch out to the left, and making sure that it's all connected, because that's going to be our 6th wire going back to the board. When the whisker hits the stopper, it brings the signal line low because it's touching ground. The stoppers talked about in the first video, and I'll talk about it one more time a little bit later, basically say, okay, they basically tell the microcontroller to stop. We've hit a snag. Turn around. Anyway, we'll get to that in a minute. First of all, what I'm going to do is I'm going to take the long piece of wire and I'm going to solder it all along here so that we've got an inch here and an inch here. Very easy to do, but I'll do it right now and show you what I've done. As you can see, I've got whiskers on the left hand side and the right. What I've done is I've soldered one joint on the left, middle, and right, and we're going to connect one of our wires here. That is our 6th wire. It's a detection wire. So really there's going to be 5 wires. One to our detection wire, one to ground at the secondary side of our LDRs, top side of our series resistor line we're going to tie 5 volts. So that's 3 wires right there. Then we're going to have all 3 of our resistor divider lines, A, B, and C. But before we do that, what we might want to do, and really this is up to you, I'm going to do this just to show you how to do it. Because we have all that wiring on the back, if we make some cuts to the board so that these sensors are facing outwards, the wires on the back are going to keep in place. Now I'm also going to add, after I make the cuts, what I'm going to do is I'm going to add a little bit of glue just to make sure that it's still firmly in place. Now what you need to do is you're going to need to take an X-Acto knife, and you're going to need to determine exactly where the middle between the middle LDR and the right LDR is. Determine exactly where the halfway point is between those two sensors, and determine where the halfway point between the left LDR and the middle LDR is, and basically just continue to make cuts. You won't cut all the way through with an X-Acto knife, but you'll weaken it. And then what you want to do is, after you've made them deep enough, very carefully kind of snap it out. It will break, but it will not break off because of all the wiring on the back. And you can bend them out to the sides. Now once I've done that, I'm going to do that, and I'm going to add a little bit of glue, and I'm going to show you what it looks like when it's done. So as you can see, I've added a little bit of glue where I've broken the PCBs, or where I've broken the PCB on both sides, but the wires act to keep it intact before you add the glue on there. Glue isn't 100% necessary, but highly, highly, highly recommended. Make sure that your lines are straight, and that each side is proportional. I've actually made this side a little bit shorter by accident, so that's something you want to be very careful of. If you actually look at it from the bird's eye view, this side is slightly shorter than this side. But anyway, that is your sensor board. So now what we want to do is we want to interface the sensor board and all of its 6 wires to our main board. So what you want to do right now is you want to connect a long wire. They're all proportional, by the way. You want to make sure that they're about... Well, it really depends on whether or not you're using the wire supplied with a kit or your own wire. Thin wire is a requirement. You have to use thin wire. 1 wire here for our whiskers. 1 wire for our 5-volt line right here, our connected 5-volt line to our series resistors. 1 wire here, the left, or sorry, from this perspective, the rightmost sensor, middle and leftmost sensor. And I say right, middle, left because right, middle, left. And then 1 right here on the bottom rail for ground. Again, according to our schematic. I just wanted to touch on this again. 6 wires, whisker, 5 volts connected to primary side of the 10K resistors that are connected to each other. Ground. And then A, B, and C. So wire those up. I will show you our sensor board when it's wired up and how to interface it with the main board. Once we're done that, we'll run a test, and that'll be the end of this video, and then we'll do an assembly video. Earlier we talked about the 2 port lines on the main board. We soldered our driver to the pins on the RB side of things. This rail right here has the pins RA0 to RA7 with a ground port and a 5-volt port. Now, You can see it on the board when you purchase it, but there's the first pin is RA0, RA1, RA2, RA3, all the way to RA7, and then there's ground, GND, and 5 volts. So I wired this out, and it doesn't look very nice right now, but it will in a few minutes after we mount them. The whisker at the top here, as you can see, there's a wire. We want to connect that wire to the RA3, as you see it here, I've labeled it RE3. Connect that wire, solder it to the RA3 port on the main board. The leftmost wire for the LDR, the leftmost LDR from this perspective, right here, should be soldered to the RA2 line on the main board, which is right here. The rightmost LDR wire from this perspective should be connected to the RA0 line. The middle one, which is kind of hidden, the middle LDR wire, should be connected to the RA1. I have a label down here. Now, our 5 volt line that's connected to the top ends of the 10K resistors can be connected to 5 volts, which is the topmost port right here. It's labeled 5 volts. And again, the secondary side of our LDRs are all connected on the bottom here, and that can be connected to the ground line. So what we need to do is connect all of those wires talked about here very specifically to RA0, RA1, RA2, and RA3. And then, of course, 5 volts powering our main board, and ground, which is our DC ground. Otherwise, if we don't have all of those wires connected exactly as I just mentioned on the board, it's not going to work. So when we're done this, we're going to connect our motor, and we're going to run a quick test. And the next video will give you some ideas as to how to put it all together physically. We are now all wired up. What we need to do is apply 7 to 12 volts on our power input. The input lines are labeled V plus and ground. Make sure you put your positive DC in the V plus line, your DC input ground in the ground line. Remember, there's a button here that acts to start and stop the circuit. So what I'm going to do is I've put a little piece of tape on the motor, and I've put a little bit of black marker on both sides just so you can see it working prior to our real assembly. All of the electronics are done with one little exception, but that'll be talked about in the next video. It has to do with the whisker and the stopper. So I'll turn it on. Nothing happens. I press the button, the tag switch, and as you can see, starts to slowly move. So now what I'm going to do is I'm going to take my trusty supercapacitor flashlight, and it changes directions. Hopefully you can see that. I know it's moving very slowly, but such as it was designed. If I keep it right in the middle, it stops. So now that we know that works, it will just keep going in one direction because there's no stopper. But as you can see, it is moving very slowly. And now you might see the LEDs right here. You see some red, and that's actually showing you, if you can see the LEDs underneath, that's showing you the binary sequence that's being fed to the stepper motor. Again, if you have trouble seeing it actually moving, it is moving. It's just moving very slowly, as per my demonstration video. Anyway, so we were lucky, no problems. We soldered everything together perfectly the first time around, no problems. I forgot to mention, when you connect the motor, it really only fits in one way. The connector's on the top. Don't try to force it in the wrong way. Look at it, look at the connector, look at the wire connector. It should slip right into place. Again, once you're done that and you've proved that it works, when you apply light to one side, the motor will turn one way, apply most light to the other, and in this case it stops because there's most light is on the middle sensor. And so once we prove that it works, we're ready to assemble. Now, for the assembly process, is going to require a few more materials at your end that will not be provided with the kit, but we'll touch on that in just a minute. If you haven't seen the first video, I suggest you watch the first video, just the demonstration, and if you're building along with me, make sure to follow on to the third video. Thanks for watching, everyone.